my name is Karsten Silz, and today I want to tell you how you can get better Java projects faster with Jhipster through learning by coding. So the slides and the code are available at this URL. I'll show it again at the very end as well. So, take a picture now. I'll also post the URL in the chat, or you can just take a picture now for the QR code. But again, you'll see it at the very end. So I've got two questions for you. The first question you see right here: do you pick technologies and tools for Java projects? The second question is, can you learn from running code? If the answer to both of these questions is yes, then Jhipster is for you. Why? Because you can get better Java projects faster by learning from running code. Now, as you know, today on the internet, everybody can tell you anything, and they literally do. So why should you believe me? Well, I think the reason is that I've got 21 years of experience being a Java developer, picking technologies and tools. So what is so important about technologies, picking technologies and tools today? Well, I've got a hypothesis here, actually two of them. The first of them is that Java developers today pick more technologies and tools more often than ever before. So that's the first hypothesis. The second one is that learning by coding with Jhipster makes that better and faster. And in the next 45 minutes, I want to prove both of those to you. And since that can be a very dry affair, I've got three helpers here. So I'm pleased to introduce Adam, the architect, Therese, the tester, and Steve with his side project. So these three guys are going to help me showing you how you can learn from running code. So what's Adam's deal? He's the architect. So his task, his mission is to evaluate how to replace an existing Java Enterprise Edition monolith. So he does a lot of evaluations. He evaluates microservices versus monolith, NoSQL versus relational databases. He worries about reactive backends, fairly new trend versus traditional servlets. He wants to have a shootout of single-page application frameworks. He knows that he needs to eventually run in Kubernetes, and he wants to know how to monitor such an application. So those are all his tasks, and I hope that we can help him tonight. Next up, Therese, the tester. What's her deal? Well, she wants to better test a Spring Boot application with an Angular UI. So her first mission is to move from Maven to Gradle, goodbye XML. Then she wants to combine two projects. Currently, there's a Java project and an Angular project, and she wants to stuff that into a single project to make everybody's life easier. Then she wants to write Angular tests, component tests, browser tests, load tests. And finally, she wants to run these tools with GitHub Actions, which is the continuous integration tool of choice of her organization. And finally, we have Steve's side project. So here's Steve. And his goal is to host a small Java side application quickly on the internet and to learn about SPA, single-page applications, in the process. So first on his list, he wants to quickly build a Java backend. He wants to build a single-page application UI. He wants to have responsive layout so that his application works on mobile phones. He wants to make sure that Spring security rules, who can do what in an application, show up on the JavaScript side as well. He worries about internationalization. And finally, he needs to host that application on the internet. Now, these three examples that I have here, obviously I made them up. Those are not real people. So, at best they qualify as anecdotal evidence. But, maybe, just maybe, there's more than anecdotal evidence out there that Java developer need to pick more tools today than ever. Maybe we can actually have systemic evidence that the need for picking more technologies and tools more often has increased. So I sure do hope so, and so I'll present the first one. First is actually two, so the first two, I should say, it's shift left and DevOps. So if we look at what we have in a project, we developers, we code the application, and so we sit over here in our little sandbox writing away code. Then we've got QA that tests our application, we've got the ops guys that run the application, and finally we've got the support team that hopefully does support our application. So that's the good old days. So what's changed here? Well, two things, spelled out there at the very beginning, at the very top. So shift left. What does shift left mean? Shift left really means that developers now become involved with testing. So that means the testing functionality, shifts left, so to speak, into our box, into our sandbox. And suddenly we developers worry about testing as well. And then DevOps, you probably came across that already. DevOps means, literally that developers get involved in ops and in support. And so now, suddenly, instead of our own little sandbox over there just worrying about code, we worry about tests, we worry about running applications and about supporting them. And so that means if we worry about all of these things, we have to pick more tools and technologies to deal with them. Next stop is microservices. Microservices means that we can take one big application or the monolith and split it up in multiple applications. That's what Adam is all about. He wants to split up his monolith into microservices. So, there's different ways you can build microservices. Here's the first one. You've got, pretty boring one, Java 8, MySQL as the database, Spring on top, and then your business logic. That's a fairly boring microservice. But, you could make it a bit more exciting, different microservices. So you use Java 11, cutting edge. You use MongoDB, a NoSQL database, and you put Micronaut on top, a new framework for running microservices, specifically targeted at microservices. And so then your business logic sits on top of this stack. So when you look at that, what you realize is, you really have two different Java stacks, and the microservices means that you're probably free to choose different Java stacks, right? If you're writing the whole microservice and it's your responsibility to build it and to run it and to support it, then, within reason, you can pick different technologies. You can use something else but Spring. You can use something else but the relational database. So that's why I think with microservices, you at least have the option to choose more technologies and tools. You don't have to, you can write them all as you did before, but you do have the option to choose different tools and different technologies. Next stop is user interfaces. So far I talked about Java applications and how we're building Java applications. But if you're honest, what we really mean these days when we say we build a Java application, we're really just building a Java backend. So, for all the Java application and the build environment, all it produces really is a REST endpoint or a GraphQL endpoint or something else, something that just feeds the user interfaces. So what kind of user interfaces am I talking here? So probably most applications have a web user interface. So, we need the actual application, the client single page application these days typically that runs in the browser, and we need a build environment. And especially with web application, the build environment actually is quite complex. You've got compilers, you've got transpilers, you've got bundlers, you've got tree shaking going on, you've got minimization, it's a lot more complicated than on the Java side. So now suddenly we have, all of this on our back. Probably when you're talking about user interfaces these days, you're also talking about mobile applications, right? We've got all these advanced computers in our pockets, so a native application in many cases is something that your users desire. So we're building an iOS application and we need an iOS build environment. So somewhere down the line, we now need a Mac, right? And then obviously, we also need to support Android because those are the devices that our customers probably use. So we've got another application and another built environment. And so we look at that picture, dare I say, with horror, and we realize that instead of just one application that we've always built in the past, our Java application, we're now building actually 4. We're building our Java backend, and then we can build 3 applications on top, these 3 clients, web, iOS, and Android. So 4 applications means a lot more tools to choose, a lot more technologies to choose. Last stop here on my little journey is the cloud. Now, cloud is quite an overused term, so let me define how I see cloud here playing into things. So in our environment, when we build an application, we build it from components. Now, these days, most of the components we use are open source. We may buy some components commercially, like a database, or at least support for a database. Your organization may use some libraries as well that you carry over from project to project, and then you've got your actual application sitting on top, using these other components to do what it's supposed to do. Now, what's true for all of these things is we spend time to code, test, run, and support this. So no matter where the application gets its components from, we spend time to code, test, run, and support this. Now, along comes a cloud vendor, and the cloud vendor has a tool or technology that that he wants to sell. He or she, it wants to sell. And so the cloud vendor uses components as well. What kind of components? Well, we don't care. Why is it that we don't care? Well, it's up to the vendor to code, test, run, and support this for money. It's not our duty. It's not our responsibility. The cloud vendor does that. And so what that really opens up is that in many cases, for many of the components that we use, we actually now have a choice. We could say we substitute time for money. So instead of us spending time on coding, testing, running, and supporting this, instead we spend money and let somebody else do the coding, testing, running, and supporting. Now, I understand it's different for organizations. Some may not be able to just put things in the cloud. There's regulations and rules, but in general, I think the trend is here that you can more often substitute time for money. And so that means you're looking at cloud vendors, you're looking at their tools, so you're picking tools, you're picking technologies, that you haven't done before. And so I hope that with this last slide, I could convince you that yes, indeed, Java developers today pick more technologies and tools. Now you may see at the very end there, that's not the full sentence, right? There's some more. I'm talking about more often. So what do I mean with more often? What's that all about? So there's really 2 things that I see happening here that lead me to say that we are picking technologies and tools more often. The first one is that for the tools and technologies that we use, there is a higher update speed. So just a few examples here. JDK, if you've been around the block a bit, then you know that it took 3, 4, 5 years to get a new JDK from Sun and then Oracle. And now we're down to 3 years, pretty much by the clock for the long-term support version. And if you're adventurous, you can get a new Java version every 6 months. So that's quite a new higher update speed, and that means more change in your application because you choose to upgrade because there's new features. Then you got to spend time on implementing these features. Next is Spring Boot. As an example, it used to be once a year to getting a release, and now they're down to 6 months. So again, doubling the speed. So every 6 months, there's something new from Spring Boot for you to look at and to evaluate and to possibly incorporate. And then the last one is, TypeScript, the other side from the JavaScript side. TypeScript is quite popular. It is JavaScript with types used in many frameworks, and they get a new release every 2 to 3 months. That's a programming language with useful features. So here a much higher speed than even with the 6-month Java release cycle. So all of that leads me to believe that currently out there, yes, there really is a higher update speed. But there's also more alternatives today. So if we think back to the good old days, everybody used the Sun and then the Oracle JDK, and now we're having multiple distributions. We've got Adopt JDK with even 2 different JVMs, Hotspot and OpenG9. I gave a lightning talk about OpenG9 here in May. We've got Amazon, we've got SAP, we've got Zulu. They all have their own JDK distributions. It's up to us to figure out, which one do we want to use. Framework, also becoming interesting again. For years it was just, Spring. What else are you going to use? But now we've got the Eclipse microprofile from the JEE side, and then we've got these completely new frameworks like Micronaut and Quarkus that are, targeted at running microservices. So there, if you're building a microservice, then those are valid alternatives. And JEE may even make a comeback under the stewardship of Eclipse. So again, from just one option, Spring, you now have multiple alternatives here. And in the JavaScript world, there's just too much to mention. There's always multiple libraries for everything, and new ones show up all the time. So you can spend a lot of time just chasing things on the JavaScript side, looking for new frameworks, looking for new tools. So I hope that I could convince you that indeed we need to pick technologies and tools more often today. And what it means is that now it's polling time. So we're trying something new here, complete with some elevator music. And I'd like to ask you a question, a yes and no question. So the question is as follows. So my question is, compared to 5 years ago, do you spend more time picking technologies and tools in your Java projects today? And so, Dom, if you wouldn't mind, now is the time to actually start the poll.
Yeah, I'll launch the poll now.
So please vote with yes or no for this question. Wonderful. I see the overview here. Nearly half have voted. 20, 21. Well, thank you. Nearly everybody has voted so far. Wonderful. Think in a democracy, it's your right to vote. Okay. I'm gonna give it, we've got 25 out of 31. Probably Dom and me are not included. So 10 more seconds for everybody to vote out there. 9, 8, 7. Okay, we're at 25, doesn't move, doesn't budge. And so we end the poll, and I'm happy to report that you agree with me. 21 said yes, you're picking more tools than 5 years ago, and only 4% said you did not. Wonderful. So, that was terrible music, wasn't it? There's a reason why people don't want to spend much time in an elevator. Anyway, back to the presentation. So, yes, really, I think we've proven here that Java developers today pick more technologies and tools. You agreed with me, more often. So now there's the second thesis here that I have. Let me just close the poll here. Sorry, I need to stop it. I've got the poll window sitting here, so let me go back to my screen. Okay, so sorry for this interruption. So the second thesis I have is that hypothesis, not thesis, is that learning by coding with Jhipster makes that, picking tools and technologies more often, better and faster. So I want to start by talking about learning. So, people learn in different ways. There's different options. So what do we have? We can learn through articles. We can learn by reading books. We can learn by watching videos. We can listen to talks like you guys do. We can attend online training. We can do on-site training. we can hire consultants. And we can actually, look at running code. Now, running code is actually an interesting example, interesting case, because if you want to learn from running code, then the big question is, how do we actually get, Jhipster, sorry. Wonders of technology. So sorry, I spoiled the surprise. So how do we get running code of unknown technologies and tools? We don't know the technology, but we're still supposed to get running code. And the answer, you've seen it, is Jhipster again. So the best way for me to at least think about Jhipster is that Jhipster is our superstar developer. Jhipster picks, configures, and updates the best technologies and tools and writes all the plumbing code. That's good for a general description, but what does Jhipster do exactly? So it's an open source command line tool that does 5 things for you. First, it picks and configures technologies and tools. It generates a full Spring Boot monolith or microservice application. It generates create, read, update, delete screens, front end and back end for our entities. And it generates continuous integration files, deploys the applications. And finally, it can also update the application and the entities. So what are some of the pros and cons of what Jhipster can do? Well, the first pro is it's free. We don't need to pay anybody or anything. So we can get a complete project with UI, build, test, and monitoring. That's not true for some of the other ways to learn out there. We can use our own data model. That's pretty rare. You probably have to hire a consultant to carry your own data model into some training. We get production level code, and we have up-to-date libraries. Some of the cons are you just get a limited selection. I said Jhipster picks the best libraries. That doesn't say all libraries, it just picks the best. Sometimes Spring Boot updates are pretty slow, and the UI is not really consumer friendly, so you're going to see that. So given all that, what can we actually learn about technology or tools from running code? Well, if we want to configure a technology or tool for our environment, can we do that by running code? I would say yes, we can fully do that. So, our 3 heroes here, Adam, Therese, and Steve, are happy. Best practices. Can we find out best practices from running code? I would say yes, some. You can look at the code, you can see its structure, you can see the configuration. So here in this case, Therese is happy because she's supposed to write tests in JavaScript, and Steve is happy because, he needs all the help he can get. He puts a complete application out there. For a low complexity technology tool, can you learn that just from running code? And I would say yes. So Therese can learn how to turn a Maven build into a Gradle build, and Steve can do the same and do some other things in his application. So for low complexity technology tools, I would say you can fully learn it just by looking at running code and running code. For high complexity stuff, like Angular, there's no way. You can't learn Angular just by looking at Angular code. You can learn some, you can see the structure, and if you've been around the block, you see patterns on how files are structured and what are their types and methods and stuff like that. But you do need something else. So I would say here the only one who's happy is Steve, because if he wants to use Angular, then he still needs to get an Angular course or Angular book or get some sort of Angular training. And then finally, for comparison of technologies and tools, I would say yes, you can get a lot of value just by running code. I mean, this is where Adam comes in. He's ecstatic because he's just doing comparisons all day long. Angular versus React, NoSQL versus SQL, monolith versus microservices. And so I think he can get a lot of mileage out of running code. 2 projects, they only differ in that one technology that he wants to evaluate. And Steve's happy too, because he's got to figure out how to do his UI. But let me emphasize again, learning from running code is not enough in most cases, but it leads to better results faster. Now, after that much talk, I'd like to actually get the demo started. So first of 2 Jhipster demos today. What are you going to see? Hopefully, if the demo gods smile upon me tonight, you're going to see how we can generate our application. So let me switch to the terminal. This is my demo directory. You see it's empty except for a data file here. Let me switch to the browser. You see there's nothing running at port 8080. So let me go back to my directory and type the first command. So it's really actually 3 commands. So first I'm going to invoke Jhipster, and it's going to lead you through the application creation. Then I'm going to import the data model. We're going to be talking about the data model here in a few minutes. And at the end, I'm going to start the Gradle application. So let's get started with launching Jhipster. Okay, so the first decision that we need to make here is, do we want to build a monolith or do you want to build a microservices? Now here for our example, we want to go with a monolith. Here we could use build a reactive application using Spring Web Flux, but we are fine with just using good old servlets. The base name of our application and the package, I just accept the defaults, and no, I don't want to use the Jhipster registry. Now there's another more meaningful choice. How do we want to do authentication? Do we use JWT, Java Web Tokens, OAuth, or HTTP? I'm going to use JWT. It's the easiest. For OAuth, I would have to run a directory server. Now we have to decide, another fork in the road. Do we want to use relational databases or NoSQL? We've got 4 NoSQL databases supported here. You see them listed, but I'm old-fashioned. I'm going to go with Postgres, and I'm going to use H2 as my development database, so an in-memory database. I could use Postgres, but I've made good experiences, had good experience with using H2 during development. For cache, we can use local cache or a distributed one. We've got a simple use case here, so I'm going to stick with a local cache. I want to use Gradle. I could also choose Maven. There are some more fancy things I can put into the application. I don't want any of them. For the UI, I've got 2 choices here, Angular and React. There is a 3rd choice not available directly in the application. It's Vue, another popular framework, but you have to use a plugin, and Jhipster calls it a template. So right out of the box, you just get Angular and React. I'm an Angular fan. I don't want to customize the theme. And yes, I do want to have internationalization. We use English as the base language, my native tongue as a secondary language, and finally Russian as a 3rd one. I had 10 years of Russian in school, so let's see if I can read what's on the screen. Now we've got some testing frameworks. The unfortunately named Gatling is a load testing tool. Cucumber is behavior-driven testing, and Protractor is a browser end-to-end testing tool. I'm not going to include any of them for the purposes of this demonstration, but they are available. I don't want to install anything else, and with that, we are off to the races. So now Jhipster is doing its thing, and I'm switching back to the presentation. So what did we see? Well, we saw that Jhipster picked and configured technologies and tools. It didn't offer all the JavaScript SPA frameworks out there. It just had 2. The same for NoSQL databases. It picked a few, but those that it picked, it configures them. Jhipster started creating our project and our entities. We did pick the architecture, the monolith, and we also picked technologies and tools like Postgres and Angular. So if we look at what we've achieved and what did we now prove by doing the first of 2 demos. If we look at what Jhipster does, well, all we can say so far, all we've seen is that we can pick and configure technologies and tools. The other for things that Jhipster does. We haven't seen them in action. So let's look at our three heroes, our three examples. Let's start with Adam first. So Adam, I'm just going to claim success here. We saw that we could generate a microservices as well. So I'm saying, yes, this tool is good enough for Adam to evaluate microservices versus monolith. We saw the choice of NoSQL and relational databases. So I'm going to say, yep, that's victory as well. We saw that Adam can choose a reactive backend, and we have, at least two through the view template, also three different UIs. So I'm just going to say, that's okay. We didn't see running in Kubernetes, and we didn't see anything about monitoring the application. So now on to our next participant, Therese the tester. We saw that we can move from Maven to Gradle. The application did spit out a Gradle build system, at least that's what we hope. And we saw that the Jhipster gave us a chance to configure browser, load tests, and component tests. Now on to Steve. Fortunately, Steve hasn't really gotten a whole lot. All we saw is that we can pick a single page application UI framework, but that's about it. So now while the application is still being, is cooking in the background, just a few more questions. So important question when you come across a new technology or tool is, is that safe to use? Will it die? Does it have support? And so from my perspective, I would say, yes, it's safe to use. It's a stable project. Version 1.0 came out 6 years ago. We're currently at version 6.10 from July. Unlike Grails, Jhipster adds no proprietary layers. If you know Grails, Grail is a framework with somewhat similar goals as Jhipster to generate an application, but the way it goes about it differs because it has its own persistence layer, it has its own view layer, so you're always dependent on Grails to get your work done. With Jhipster, it's different. There are no proprietary layers. You get a Spring Boot application with Angular here in this case, and there's only a thin layer, just one Maven library and one NPM library that Jhipster adds to the mix, and that's security and internationalization. Everything else is really just best practice code that Jhipster creates. And that's why I said Jhipster really is like a superstar developer, not a framework, because then I think it's easier to imagine that a superstar developer wouldn't add proprietary layers to your code. It would just write best practices code. So what it really means is that now that we're generating our application, after we're done with it, we could really just stop using Jhipster after we generated it and just maintaining it by hand, so to speak. One last snippet here, the Jhipster lead developer has been a Java developer advocacy manager at Microsoft since 2019. So I think that's a good sign as well. So how popular is Jhipster? Has it become more popular or less popular? So you can track how many users, how many people download that Jhipster generator. And so here we can see the statistics. So from 2015, which is where that tool started counting, all the way through 2020, we see an upward trend. And so I started using it in early 2018, where there were probably about 12,000 downloads, and now we are at, I want to say, 37,000 downloads. So in the close to 2 years, 1.5 years, 2 years, good 2 years that I've used the tools, usage has tripled. So I think that's a good sign as well. So how can we get Jhipster? Well, you install it with NPM. So you need to have Node, the Node framework on your machine, and more specifically the LTS version, which is version 12 right now. You also need Java and Git, but you probably have that anyway. And it's recommended to have Docker because a lot of the tools, databases, build tools, stuff like that, Jhipster gives you Docker files or Docker Compose files, so without it really being a bit restricted in what you can do. Now I said at the beginning, and that's the last piece before we do our second demo, that Jhipster, we can bring our own data model. So how does it work? Well, The answer is Jhipster has a domain language. It's called JDL, Jhipster domain language. And this is where you define your data model. So how does it look like? So you define entities. You see one here. I'm going to give you a moment to look at it. Okay, so what we're seeing here is really entities with attributes, string, number, blobs, and some constraints like whether it's required, minimum length, maximum length. And in the application later on, these entities will become JPA entities. You can also define relationships. Here we have a one-to-many relationship between product category and product. And it's easy to imagine all four possible relationships: one-to-one, one-to-m, and one-to-many, many-to-one, and many-to-many. They're all supported by Jhipster. And the last part of the JDL is configuration. Here, for instance, we've got a backend configuration. You see the second line where we say we want to create data transfer objects. So we don't want to pass around our entities in the business layer. We want to use data transfer objects. And on the front end, in our Angular client here, we want to have pagination. So, and I hope that now the application is ready for us. So in that second demo, I hope I can show you the user interface, how to do continuous integration, and how to go about deploying the application. So let me switch back to my terminal, and we see here that Spring Boot is running. That looks good. So let me refresh my browser. And we've got an application here. So that's the application that Jhipster generated for us. It's built in Angular and uses Bootstrap under the hood. So we've got the menu line here at the top, we've got a footer, and we've got a content area here. So first thing I'd like to show you is we can switch languages. Here's my native tongue, and that actually does look correct. And сейчас мы говорим по-русски. Очень хорошо. So I think I still know a little Russian, but let's switch back to English. So we've seen internationalization works. Let me sign in. I'm going to sign in as the admin. And so now I've got two more options here in the menu bar. I see the entities and I see administration. So let me take a look at product first. So this is the table that Jhipster generated for the entity that I defined. See, all the attributes are listed here. I can view, edit, and delete. So let me view that. So this is how the entity looks like. I'm just gonna edit it, change the name to Hello World. So now I saved it. It says Hello World here, and oh, the wonders. I actually did update the entity. So it's not all smoke and mirrors. Okay. So, the UI is nothing to write home about. I think it's okay for an internal tool, but that's nothing that I would give to, the consumer. Administration. So, but anyway, I think Steve has a good base to build upon. Now, Adam is going to be happy about this screen. As you may recall, he worries about monitoring. Jhipster creates, a whole bunch of monitoring screens for us. So here we've got one where we see some JVM metrics, some details about garbage collection. We see statistics about our API endpoints, how often they've been called, how long it took. We see details about our Hibernate caches and some data source statistics. So that's pretty good for something that you get for free here in the application. Now let me sign out and sign back in as a user. Now I'm logged in as a user, and I still can see the entities, but the administration menu is gone as it should be. And that's a feature that Steve will be happy about, because the Spring Security user role of user and admin, do get moved forward to the UI in the UI update. So Angular knows about the Spring security rules. Now, the last thing I want to do, since we talked about users and having mobile phones, I want to switch to a iPhone 6 or 7 layout here in Chrome with the Chrome DevTools. So on a phone, you've got the typical hamburger menu with the options here. Go away. So I want to say it's okay. It's not great. The buttons are a little smaller. I think you can still touch them. So you can definitely do some more work, but out of the box, you get something that passes for a responsive layout. So that concludes the demo, and I now want to show you come to deployment. So the first one is one for Therese. Therese needs to create continuous integration build files. And so Jhipster supports a bunch of them out of the box. I would say probably the most important ones are here. We've got Jenkins, Azure Pipelines, GitLab, GitHub, Travis, and CircleCI. We want to have GitHub Actions. There's some more things we could do, but they all require some more answers. I don't want to give them, so I'm just going to say just a plain GitHub Actions file, and we've got that here. So Therese could now go ahead and do a continuous integration with GitHub Actions. Now, Steve eventually needs to deploy the application, and he picked the Google App Engine, which, surprise, is supported out of the box by Jhipster. And so the Google App Engine generator starts up, and now it will ask you a bunch of questions, which hopefully will lead to the application being deployed in Google App Engine. I don't want to go through with that because we still have Adam here, and Adam's mission is to deploy to Kubernetes, and that's also supported by Jhipster. So we can decide whether we want to deploy a monolithic application or microservice. Here in this case, it would be a monolith, and then a lot more questions, and we don't want to go through with that. But we've seen that we can deploy to Google App Engine and Kubernetes. So that concludes our second and last demo. So what did we just see? We saw that Jhipster finished the project and the entity generation. We saw the actual application. We configured continuous integration with GitHub Actions, and we started to configure deployment to Kubernetes and Google App Engine. So what did we prove with that second demo? So let's pull up the task sheet here for Jhipster. We saw a full Spring Boot monolith being generated. We saw the create, read, update, delete screens for our entities. We saw the CI files and how the Jhipster deploys the app. Well, 4 out of 5, not bad. Adam had 2 things on his list left: run in Kubernetes and monitor application. And surprise, surprise, we did see at least the beginnings of running in Kubernetes, and we saw some way of monitoring the application. Therese did see the combined Spring Boot and Angular Git project in action, and she also saw that she can run tests with GitHub Action. So she's happy. Steve, didn't have much in the first demo, but now it's a full slam. So quickly building a Java backend, we saw that we could change the data that was generated. We saw the responsive layout. We saw Spring security in JavaScript, internationalization. We did see, and we saw the beginning of hosting the Java application on the internet in the Google App Engine. So really, our 3 heroes here, they're all happy because all their tasks are complete, which is a wonderful feeling. Now for Jhipster, you see at the very bottom, we still have 1 point left, updating applications. We haven't seen that, and we're not going to see that. I'm just going to tell you about it. So updates. How do updates work in Jhipster? Well, Jhipster can update libraries and code, so you can get a new Spring Boot version, a new Angular version, stuff like that for your application and your entities. How does that work? Jhipster actually regenerates the application or the entities on a separate Git branch. And it's then up to you to manually merge this newly generated application or these newly generated entity screens into your main branch. And yes, that means your code changes can get overwritten by Jhipster, and how to avoid that is barely documented. So that really sucks for Steve, and by the way, it sucks for me as well. You can figure out ways around that, but it is not documented, so that's definitely a pain point. Now, talking about update, how often does Jhipster update stuff? So Spring Boot, is the linchpin of Jhipster. It took 6 months for Jhipster to pick up Spring Boot 2.1. It's got a bunch of dependencies. Spring Cloud Task, I believe, is the one that usually takes a while. It was a lot faster for 2.2 last fall. It just took 3.5 months. But the latest version that came out in May, the first one on that 6-month release cycle, 2.3, still not supported. I'm not sure it ever will because 2.4 is just around the corner. I think it's scheduled for October, so a mere 2 months away. Angular goes a lot faster. Angular goes a lot faster. The 9.0 release, which had a lot of changes, just took 1 month, and Angular 10, a smaller release in scope, it just took 4 days for Jhipster to pick that up. But sometimes Jhipster also just switches out stuff completely. So for instance, when I started with Jhipster, Yarn was the build tool, and then somewhere along the way, Jhipster switched to NPM. It's kind of like a Gradle Maven situation there on the JavaScript side. But sometimes it also completely switches tools. So when I started, the JavaScript test runner was Karma, and then along the way, Jhipster switched to Jest. So, that's one of the reasons why you sometimes have to regenerate the entity, because otherwise you wouldn't pick up, these new libraries that your tests now depend upon. So I hope that I could convince you that, yes, Jhipster does update applications and entities. So we're now complete here as well. And I hope that I proved that Jhipster helps Adam, Teresa, and Steve achieve their goals, and that I also proved that Jhipster does what it should. So my second hypothesis, that learning by coding with Jhipster makes picking tools and technologies better and faster. I hope that you agree with me. Yes, I've actually shown that. And so now both of my hypotheses are proven, at least as far as I'm concerned here today. And so that really means, I think, to me at least, that Jhipster gives you better Java projects faster by learning from running code. And this is the end, my friend. So thank you for your attention. And as promised, here are the slides again, a link to the slides and the code. So I'll also put that into the chat. Dom, back to you.
Thanks, Karsten. I'm just filling in for Dom. So
okay,
we have few questions in the chat window. I'll just read it for you.
Okay, please.
The first question is from Gun Tarhal. Can we edit and work with IntelliJ, for example, in this case? Is it understandable?
Yes, you can. If you go to that link that you see there, then you'll get to an article on my webpage where I've got a 3-part tutorial, and one on Jhipster. And in the third part, I describe in detail how to import the project into either Eclipse and IntelliJ, how to run it there. So, from the perspective of IntelliJ, it's a Spring Boot project, and the Angular part gets also configured, but it really is all driven by Maven or Gradle as your build system.
Just on the same question, how readable is the code, like in terms of the generated code? Although it's a skeleton, how readable it is in terms of readability?
I would say that, I would stand by saying that it's best practice code. So it's not, trying to be overly clever. I think it's relatively obvious how it does things. I don't think if you look at the code, then it doesn't try to do very fancy things. Now, truth be told, on the Java backend side, there isn't really a whole lot of code, because you're dealing with entities, you're saving them. So you're doing a little bit of validation and then you're firing stuff away. So there isn't really a whole lot of complicated code there. On the Angular side, I've only worked with Angular. You've got a bit more freedom on how you want to structure things, but there it's best practices as well. For instance, in Angular side, it creates different modules. So when you create your new entity, they're all put into separate modules and then they're being lazily loaded. So you get a well-performing application.
Cool, thank you. Next question is from Timothy. How does monitoring page work? Does it use Spring Actuator under the hood? How would that work if we generated example Micronaut service?
Yes, that is true. So the pages that you saw here, and then again, if you go to my webpage here, you see a link in the second tutorial. I go through all the admin screens. Yes, that's all code that's based on the underlying Spring Actuator. You saw the one page here that had all these JVM metrics. There's another page that tells you about this space. You've got, you configure log levels in details. You've got, another page that tracks who's logged in real time, so you can see which page they're on, that uses WebSocket. So as far as I'm aware, it's not additional library. It's all just code being built on top of Spring Actuator. That's why I think it's, if you build something on top of Spring Actuator, then you can use that as a template to implement in your own project. I haven't worked with Micronaut or Quarkus or any of that stuff, so I'm not sure how you would, create a similar admin screen out of that.
Cool, thank you. That was the last question. I had another question. We understood like we can use Jhipster, to start a project with the skeleton. But then I was wondering, for example, we have a Spring Boot project and we want to move to Micronaut, for example. Would Jhipster help with that?
No, in that case, well, I think it would help somewhat. So how would that be? I mean, if you think about what I said is that, sorry, one step back. In most cases today, a Java application is a backend that delivers data through REST API, GraphQL API, pick your poison. So so for everything on the other side, for the UI side, you could certainly use that because you're just running against a REST API. Now for the actual Java backend side, you can't switch out Spring Boot for something else and have it being supported by Jhipster. So you can see, you can maybe learn a little bit by looking at, how are the entities being done? How do you create a data transfer object with a map struct? How do you create the build system? How you do all that stuff? But, the core is built on Spring Boot. So Jhipster can't help you here on moving to another framework. You may get, but I don't know, you may get some help on how to build these admin screens, but again, it could be that most of that stuff relies on Spring Boot things.
Yeah, makes sense.
So I would expect little help there for alternate frameworks on the backend side.
Makes sense, yeah. And sorry, I just had one more question.
Okay.
You also mentioned about the quality of the code, right? Like obviously it follows the best practices to generate the skeleton code, but do we get any like static analyzer tool as part of Jhipster or not?
Jhipster uses different linters. So there's a linter on the Java, on the JavaScript side, on Angular side. They took the lead on a linter for Java as well. I think that's like a project that they spun off. You do get support for SonarQube. I personally haven't used that with Jhipster. So when you create a project, there's a SonarQube Docker Compose file, and I think it's already kind of wired up so that you could use that too. There is a little bit, from the typical suspects, PMD check style. I think they use check style for a couple of checks, but there is no built-in find bugs or PMD configuration. So that's something that you would have to put on top and then integrate into the build. So out of the box, SonarQube and a little bit of check style and Java and JavaScript linters.
Thank you. We don't have any more questions. So.
Okay, well then, thank you for staying up in these stormy hours here. It's quite quite windy up here in Milton Keynes. So thank you for your introduction. Again, if you're interested in learning more about Jhipster, here is the URL. Take a look at that page, look through these tutorials, and I hope that, I could help some of you doing your job and, getting better projects faster with Jhipster in the future. Thank you.
That was a great talk. Thank you.